Question number 13. This question is based on principle of calorimetry, which states that for an isolated system, the amount of heat given by one part of the system is equal to the amount of heat taken by the other part of the system. Question में ये कह रहा है कि there is a copper ball. It has got mass 100 gram and it is kept at a temperature T. It is dropped in a copper calorimeter of mass 100 gram filled with 170 gram of water at room temperature, which is being mentioned at 30 degrees centigrade. The specific heat of copper is 0.1 calorie per gram per degree centigrade, whereas the specific heat of water is 1 calorie per gram per degree centigrade. Now, once we put the copper ball inside the calorimeter plus calorimeter, then the final temperature is obtained to be 75 degrees centigrade. Now, the water kept in the calorimeter and the calorimeter initially had a temperature of 30 degrees centigrade, and since the final temperature is 75 degrees centigrade, it means that they must have taken heat, and it only indicates that the copper ball must have been at a temperature greater than 75 degrees centigrade, and it must have lost heat in the process of heat exchange. So, we will use the principle of calorimetry, which says that heat given is equal to heat taken, and heat will be given by the copper sphere. It is going to be equal to 100 into 0.1 into T minus 75. Heat taken will be by calorimeter, that is the mass of the calorimeter is 100 gram. So, 100 into 0.1 into 75 minus 30 plus the water which was there in the calorimeter, it has got mass 170 gram. So, this is equal to 170 into 1 into 75 minus 30. If you solve it, you will get the value of T to be equal to 885 degrees centigrade. So, the correct answer is answer number 4. Question number 14. This is a very simple question, and it uses the definition of kinetic energy, and other than that you just need to solve a basic equation of no force. The question says that a body of mass 10 raised to power minus 2 kg is moving in a medium and experiences a frictional force F is equal to minus kV square. Its initial speed is V naught, given out to be 10 meter per second, and it is given that after 10 second, after a time gap of 10 second, its energy is equal to, kinetic energy is equal to 1 by 8 m V naught square. Since kinetic energy after 10 second is 1 by 8 m V naught square, we can easily calculate that what will be the speed of the particle after 10 second. We can write kinetic energy 1 by 8 m V naught square is equal to half m V final square, and we will simply get V final to be equal to V naught by 2, which is equal to 10 by 2, that is equal to 5 meter per second. Now, under this, the influence of this force, the particle's speed is changing from 10 meter per second to 5 meter per second in a time span of 10 second. So, we will use the equation. The mass of the particle is given out to be 10 raised to power minus 2, 10 raised to power minus 2 dV by dt is equal to minus k into V square. dV by V square is equal to minus 100 k into dt. Just integrate it from 0 to 10, integrate it from 10 to 5, and from here we will get the value of k to be equal to 10 raised to power minus 4 kg per meter. So, the correct answer is answer number 1.